Welcome back to the MegaNet Software channel. I'm absolutely thrilled you're here today because we're diving deep into an explainer that serves as your ultimate foundational guide to mastering Git and GitHub. Listen, if you're a software developer, a data analyst, an AI integrator, or maybe a tech student looking to level up your skills, you are in exactly the right place. So let's jump right in and transform how you build software forever. Okay, picture this scenario. You've spent 3 grueling weeks building a seriously complex feature for your application. Maybe it's a massive enterprise payroll engine written in C#, or a custom data analysis script in Python, or even a cutting-edge AI workflow. Everything is working perfectly. But then, it's late at night, and you decide to make just one tiny tweak to optimize a database query. You hit save, and suddenly, boom, the entire system crashes. You're furiously hammering the undo shortcut, but it's too late. The file is saved, your previous working logic is totally gone, you don't even remember which exact line of code broke the app, and worst of all, you have absolutely no backup. Look, this exact nightmare has happened to almost every technical professional at least once. And because of that panic, we've all resorted to this absolute chaos of untracked files, right? You know the drill. Naming files final, and then final, and then use this one, please. It is a completely disorganized mess that leads straight to lost work and immense stress. But the most crucial thing I want you to take away right now is that in modern engineering, this stress is completely 100% preventable. To get you out of that chaos, here's our syllabus for today's explainer. First, we'll cover the version control lifesaver. Second, Git versus GitHub explained. Third, we'll explore the 3-stage local architecture. Fourth, cloud sync and branching. And finally, we'll wrap the whole thing up with a daily command cheat sheet. Let's start with Section 1, the version control lifesaver, the foundational bedrock. So here's the deal. Mastering version control isn't just some optional skill you can casually pick up later on. It's the foundational bedrock of all professional technology workflows. Whether you're writing production-grade enterprise software, building custom AI agents, managing complex database schemas, or even just starting your journey in tech, these tools are absolutely indispensable. Mastering them isn't just about avoiding silly mistakes. It acts as your safety net, your collaboration engine, and honestly, your public proof of competence to potential employers and clients. Moving right along to Section 2, Git versus GitHub explained. Clearing up the confusion. Before we even think about touching a terminal, we need to clear up what is literally the most common point of confusion for newcomers. Git and GitHub are absolutely not the same thing. They're two different beasts. First, we have Git. Git is a local, distributed version control system that was actually created by Linus Torvalds back in 2005. It runs directly on your computer's operating system, completely offline. The best way to think about Git is like a supercharged, high-precision camera for your project folder. It takes precise snapshots of your entire directory, meticulously tracking every single line you add, modify, or delete. On the flip side, we have GitHub. GitHub is a cloud-based hosting service and collaborative platform. So if Git is the camera taking the snapshots locally, GitHub is the secure online photo gallery and workspace where you upload, share, and collaborate on those snapshots with developers all over the world. GitHub brings massive features to the table, like team access control, automated testing pipelines, and issue tracking. When you use them together, they give you complete data redundancy and totally seamless teamwork. All right, Section 3, 3-stage local architecture. Let's build that local mental model. Let's shift gears from high-level theory down to how Git actually manages files locally on your machine. The absolutely crucial concept to grasp here is that Git doesn't just blindly save everything all at once. No, it uses a highly deliberate 3-stage architecture. Stage 1 is your working directory. This is just your actual file system, exactly where you create and edit files using an editor like VS Code. Stage 2 is the staging area, which is often called the index. Think of this kind of like setting up a photo studio. If you just modified 5 files, you might only want to bundle 3 of them into your next official save point, right? The staging area lets you handpick those specific changes. Finally, Stage 3 is the local repository. This is the hidden database where Git permanently stores the compressed snapshot of the files you just staged. Now, how do we actually operate this architecture? Well, let's talk terminal commands. When you install Git for the very first time, you basically have to introduce yourself to the system. Running git config -- global user.name followed by your full name in quotes, along with your email ensures that all your future work and all that brilliant code you're going to commit is properly attributed directly to you. Once you're properly introduced, it's time to start tracking a project. You just navigate inside your project directory in your terminal and type git init. This is a super simple but incredibly powerful command. It initializes project tracking by generating a hidden folder named .git. And that hidden folder, that is exactly what houses your local repository database. It's the brain of the whole operation. So as you're working away, you'll naturally want to move files from your working directory into that staging area we talked about. You do this using the git add command. For example, typing git add index.html script.js demonstrates exactly how you specifically handpick and stage files when you're happy with a piece of work. It's a very deliberate choice. You're basically telling the system, hey, these are the exact changes I want to record next. Awesome. Now that your files are staged, it's time to take that permanent snapshot. You do this by running git commit -m, where that little m simply stands for message, followed by a really clear descriptive message in quotes explaining what you just changed. Something like add secure authentication logic. By constantly repeating this add and commit cycle, you're systematically building an immutable historical timeline of your software's evolution. And the best part? If anything ever breaks, you can just easily roll back to a previous working commit. No more panic. Moving to Section 4, Cloud Sync and Branching. Time for team collaboration. So far, we've only been talking about local commands. Let's step up to professional cloud synchronization. Once you've got some local commits recorded, it's time to sync your work with GitHub Cloud. First, you'll log into GitHub and create a new empty repository, which gives you a unique web URL. Then, you link your local machine to that cloud repository by running git remote add origin followed by that URL. Finally, you safely back up your primary code to the cloud using the command git push -u origin main. That -u sets up your upstream tracking link, which is a fancy way of saying that any future pushes will just take one click. Just like that, your code has complete offsite data redundancy. But listen up, because here is the golden rule in professional software engineering. You never push untested code directly to the primary main branch. If you break the main branch, you literally break the software build for everyone else on your team. That's a huge no-no. This brings us to branching. A branch is essentially an isolated parallel universe. It lets you write experimental code, fix bugs, or build massive new features with absolute safety, completely separated from the stable main project. To spawn and immediately switch to a brand new isolated feature branch right in your terminal, you use the command git checkout -b, where the B stands for branch, followed by a nicely organized name, something descriptive like feature/patient billing module. While you're on this branch, you can edit, stage, and commit completely isolated from the main system. You can't break anything. When your brilliant new feature is finally complete, you push that isolated branch up to GitHub, but you don't just force it into the main project yourself. Instead, you open what's called a pull request, or a PR. A pull request is basically a formal notification inviting your senior developers and peers to review your work. They're going to inspect your code line by line, leave comments, suggest optimizations, and run automated tests. It acts as the ultimate quality assurance gateway before your feature is allowed to cleanly merge into the stable mainline. Finally, Section 5, the Daily Command Cheat Sheet. Let's look at your daily toolkit. To wrap up this explainer, I want to quickly recap these 4 commands. They are your daily toolkit to stay synchronized and safe. First, git status instantly checks the current state of your working directory and staging area. Use it all the time. Git log --online gives you a really clean chronological history of all your past commits. Git pull origin main downloads and merges the latest updates from your team on GitHub, ensuring you never fall behind. And of course, git checkout -b spawns that new isolated branch whenever you start your next feature. I really want to leave you with this final thought. By truly integrating Git and GitHub into your coding routine, you're doing so much more than just protecting yourself against catastrophic data loss. You are mastering professional engineering workflows, and you are building a living, breathing, open portfolio that unequivocally proves your capabilities to potential clients, collaborators, and future employers. Well, that's it for this explainer. Thank you so much for joining me. If you want to connect with other developers and analysts, make sure you join the MegaNet software community on WhatsApp using the link down below. Come share your GitHub profile, collaborate on exciting projects, and grow your tech skills with all of us. I'll leave you with this one question to think about. Now that you actually hold the keys to a fail-proof engineering workflow, what is the very first project you're going to safeguard with Git today? Keep coding, keep committing, and keep building.